This is the 6.3 mini lesson. Problem 1 is on factoring. So you can use the distributive property in reverse. So consider this expression, 7 times 26 plus 7 times 14. Since both 26 and 14 are being multiplied by the same number, 7, the distributive property says you can add the multiplicands together first, then multiply their sum by 7 just one time. So here, they took this 7 and pulled it to the outside of the parentheses and put these two pieces inside. So you have factored the original expression. To factor an expression means to rewrite the expression as the product of factors. The number 7 is a common factor of both 7 times 26 and 7 times 14. A common factor is the number or an algebraic expression that is a factor of two or more numbers or algebraic expressions. So we're going to factor each expression. When I look here, I see that both of them have a 4 that's common. I'm going to pull that to the outside of the parentheses, but then what's still left is 33 minus 28. Here I see that both of these terms have a 16. I'm going to factor that out. What's left? 17 plus 13. The distributive property can also be used in reverse to factor algebraic expressions. For example, the expression 3x plus 15 can be written as 3x plus 3 times 5. So as you can see, they found the common factor, which is a 3, and took it to the outside, and then left the x plus 5 on the inside. The factor 3 is the greatest common factor to both terms. The greatest common factor, or GCF, is the largest factor that two or more numbers or terms have in common. When factoring algebraic expressions, you can factor out the greatest common factor from all the terms. So we're going to consider the expression 12x plus 42. The greatest common factor of 12x and 42 is 6. Therefore, we can rewrite it. If I take 6 out of here, 6 times 2x gives me back the 12x, and 6 times 7 gives me back the 42. So by using the distributive property, I would get this back. It's important to pay attention to negative numbers. When factoring an expression that contains a negative leading coefficient, it means the first piece, when that first number is a negative, or the first term, it is preferred to factor out the negative sign. Let's star that because that's something that often gets missed. A coefficient is the number that is multiplied by a variable in an algebraic expression. So in 12x, 12 is the coefficient. If it were negative, we would want to factor out that negative sign. So how can we check to make sure you factored correctly? So if we look at this expression, you can think about the greatest common factor as being the coefficient of negative 2. So negative 2 times x plus, in order to get a positive 8 here, it would have to be negative 2 times negative 4. So what they did is factored the negative 2 out. What's left? X and then a minus 4, or x plus negative 4. So let's look at this. I see that 7 goes into both of these, so I'm going to factor out a 7. So I'm thinking 7 times what gives me back 7x? 7 times x. And I'm thinking 7 times what gives me back positive 14? And that would be positive 2. Okay, let's look at this one. I know that minus 27 is the same thing as plus negative 27. You will not see those double signs very often, so I'm going to try to break away from those now. So I see that 9 goes into both of these. If I factor out a 9, 9 times what gives me back 9x? 9 times x. 9 times what gives me negative 27? Negative 3. or I could say plus negative 3. Again, double signs is not preferred, so I'm going to write it like this. Okay, looking here. The biggest thing I see that goes into 10 and into 25 is 5. So I'm going to factor out a 5. So I'm asking myself 5 times what gives me 10y? So it would be 2y. Now I'm saying 5 times what gives me negative 25, negative 5. Try one more here. The greatest number that goes into 8 and 28 is 4. So I'm going to factor out a 4. So I'm asking myself 4 times what gives me 8n? 2n. And I'm asking myself 4 times what gives me positive 28? Positive 7. Okay, I'm going to try another one because sometimes the greatest common factor is not just a number. So if I look at the number portions, I see that the largest thing I can get out of 15 and 35 is 5. But I also see that there's an n that's common to both, so I'm going to factor out the n as well. So now I'm asking myself 5n times what gives me 15mn. So 5 times 3 gives me the 15. I still need an m, and I have the n right here. Now I'm asking myself, how do I get a negative 35n? So 5 times negative 7 gives me back this, and I already have the n here. This would give me 35n negative. So I'm done. And I'm going to try one more, because remember we said when the leading coefficient is negative, we want to factor that negative out. So I see 3 goes into both of these, but I want to factor out that negative 3. So negative 3 times what gives me negative 3x? It would just be negative 3 times x. Now I'm asking myself, negative 3 times what gives me negative 27? And that would be a positive 9. Negative 3 times positive 9 gives me back negative 27. Okay, so that's factoring. But we're also working with combining like terms in this section. So if we look at problem 2, so far the distributive property has provided ways to rewrite given algebraic expressions in equivalent forms. You can also use the distributive properties to simplify algebraic expressions. So consider the algebraic expression 5x plus 11x. What factors do the terms have in common? Well, with numbers, they only have a 1, but I see that they both have an x in common. So I'm going to rewrite this using the distributive property. I'm going to factor out the x, and if I take x out of here, x times 5 would give me back 5x, and x times 11 would give me back the 11x. So now they want me to simplify. Using order of operations, 5 plus 11, I do parentheses first, is 16. And typically you would always write this with the coefficient first, so I get 16x. So the terms 5x and 11x are like terms, meaning that their variable portions are the same. When you add 5x and 11x together, you are combining like terms. So they want me to simplify each expression by combining like terms. In order to combine like terms, they must have the same letters raised to the same exponents. So both of these are AB. So because of that, I can take 5 ABs plus 22 ABs, and I know I would get 27 AB. Subtraction works the same way. These are like terms because it's the same variable raised to the same exponent. So I have 32 minus 44, or I have 32 plus negative 44. I know that my answer is going to be negative. I know that I'm subtracting their absolute values. So I get negative 12x squared. So let's take a couple more of these. I'm going to look at G. So I have negative 3z and negative 8z. These two are like terms. So negative 3 plus negative 8 is negative 11z, and then I still have minus 7. Here, if I look at this one, this cannot be simplified by combining like terms. These terms are not the same. They don't have the same letters raised to the same exponent. I could factor this, but I cannot combine like terms.